In this video, we're going to be looking at a couple of different ways of dealing with numerical data. The first involves a discussion of scientific notation, which I am sure is going to be a review for most of you. But scientific notation gives us a way of expressing numbers that is far more convenient than it would be if we didn't have it. Scientific notation allows us to take really, really large numbers and shorten them down. For example, if I had a number like see here, one. Okay, if we had a number like this, which is a number that you are going to be using more than you care to admit by the time this course is over, can you imagine having to type this into your calculator every single time? Um, I can't, so it's nice that we can take this number and simplify it down into 6.02 times 10 to the 23rd. Okay, so how do we do that? Well, let's say we just had a smaller number, so we don't have to do all the counting. Okay, so let's say that we have a number, actually let's put a 2 in front of that. There we go. Okay, so let's say we have a number like this, and we want to convert this to scientific notation. The first thing we do is we draw in the assumed decimal point at the end of the number. And we're going to take that decimal point and we're going to imagine moving it one step at a time to the left. And we're going to do that until we get to the point where there's only one digit to the left of that decimal point. And what we wind up with is 2.6. Then we look at the number of times that we moved that decimal point to get it to where it was. 2, 3, 4, 5 moves. So that works out to be times 10 raised to the 5th power. Okay, and that's how we do that. Now, if we wanted to go in the opposite direction, let's say we had a number like 1.38 times 10 to the 8th. Well, the way we would handle that is by first writing down that 1.38. Then we're going to grab that decimal place and we're going to move it 8 times. So it'll be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then for every one of those steps that we took, we can fill in a 0. Okay, so that at the end, what we wind up with is this. $138 million. And that's our final answer there. Okay, so we can go back and forth between the two. Now, I said earlier that we can use this for very, very large and very, very small numbers. So here's a small number that you're going to encounter probably right around chapter 7. Okay, this is a very small number that's used to describe things that are happening on the atomic scale. So super tiny. And again, if we had to write this out every single time or type this into our calculator every single time, that would be quite cumbersome. So instead, we can express this as 6.626 times 10 to the negative 34th. Okay, so how did we do that? Well, first of all, notice that we have a negative exponent there. Okay, that's what's going to cause us to move the decimal point in the opposite direction. So let's say we have a number like 0.00055. Okay, just like we did before, we're going to look at the decimal point. Now this time we don't have to worry about drawing in the assumed decimal point because it's right there. And we're going to move that decimal point to the right this time. And again, just till we get one non-zero digit to the left of it. Okay, and you can see here we had to move this 1, 2, 3, 4 times. So what we wind up with is 5.5 times 10 raised to the power, well, it would be 4 except we moved it in the right, or we moved the decimal point towards the right. So this is -4th. Okay, now we can go in the opposite direction just like we did before. Okay, so let's say I had a number like 8.35 times 10 to the -3rd. We start off by writing down the number, and we're going to move that decimal, this time to the left, 3 times. 1, 2, 3. And again, we're going to fill in zeros where those little valleys are, and for good form, we're going to put a 0 in front of that decimal point. So this becomes 0.00835. And that's it. That's how we handle scientific notation.